Welcome to the Deep Dive. Today, we're digging into a really fascinating bit of research. It tackles something you've probably encountered online: AI-generated product reviews. Specifically, how hard they are to spot.
That's right. And this paper focuses particularly on Tamil and Malayalam, which is interesting because these languages often get less attention in AI research compared to, say, English.
Exactly. And what's cool is how they systematically tested a whole bunch of different methods, everything from, traditional machine learning all the way up to the latest transformer models.
They're really trying to figure out what works best for telling apart real human reviews from AI-generated ones in these specific languages. It's pretty important stuff.
Absolutely. So if you rely on online reviews, especially in Tamil or Malayalam, or if you're just interested in this whole AI content detection challenge, this is definitely relevant.
Yeah, the rise of things like ChatGPT means AI can write incredibly convincingly now. It makes it tough to know what's genuine. This research helps understand how we might keep online marketplaces trustworthy for millions of people.
And they tackle it in low-resource languages, too, where there are fewer tools, less data. That makes it even more valuable, doesn't it?
It really does. And for anyone keen to explore further, they've actually made their data set and code available, which is great for the research community.
Okay, so let's get into the meat of it. What was the main goal here? What did they actually set out to do? And, well, what did they find?
So the core task was basically binary classification. Can a machine learning model look at a product review in Tamil or Malayalam and say, yep, that's AI, or nope, that's human? Simple goal, but tricky to get right.
And they threw a lot of different models at it.
Oh, yeah, a whole spectrum. They had the traditional ML classics, SVM, Random Forest, XGBoost. They even combined some in an ensemble.
Okay, the standard toolkit.
Right. Then they moved into deep learning with a CNN plus Bill STM model, and then the big guns. The transformer models, things like IndicBERT, Mural, XLM, Roberta, and even a specific MalayalamBERT.
Wow, that's a pretty thorough lineup. So how did the old guard hold up against the newer transformers? Did the established methods compete?
Well, it's kind of what we're seeing across a lot of NLP tasks these days. The transformer models, generally speaking, came out ahead. They just seem better equipped for understanding the nuances of language.
Any specific winners?
Definitely. For Tamil, the standout was IndicBERT. It hit a 96% F1 score, which is, really quite good.
And F1 score, just quickly, that balances finding the AI reviews without wrongly flagging human ones, right?
Exactly. It's a good single measure of overall accuracy in this kind of task.
Yeah.
96% is impressive. And actually, IndicBERT did pretty well on Malayalam, too.
But was it the best for Malayalam?
The top performer for Malayalam specifically was MalayalamBERT, which makes sense since it was trained particularly on Malayalam text. It achieved a 92% F1 score. Still very solid.
Interesting. So specialized models can really pay off. Were there any results that kind of made you pause or think, that's odd?
Yeah, the XLM Roberta result on Malayalam was quite interesting. It technically got perfect precision and recall for both classes. Sounds amazing, right?
Perfect. How can that be bad?
Well, the catch was, when they looked closer, it actually misclassified a few human reviews as AI. So while it was incredibly good at spotting the AI fingerprint, maybe it became a bit overzealous.
Like it learned the AI pattern too well and started seeing it everywhere, even in real writing.
Potentially, yeah.
Yeah.
It might suggest it developed a very specific, maybe too rigid idea of human Malayalam struggling with natural variation. It's a fascinating edge case.
Definitely food for thought. Okay, so to appreciate why this research is happening now, we should probably look at the backstory, right? What led up to this?
You're absolutely right. The huge leap in generative AI, especially large language models like ChatGPT, is the crucial context. Suddenly, AI can produce text that's incredibly difficult to distinguish from human writing.
We see it everywhere in news, social media.
Exactly. And product reviews are a prime target. Even for English, a language with tons of resources, there's no single magic bullet detector. Often, you need to combine results from multiple tools to get a decent sense.
So if it's hard for English,
it's even harder for low-resource languages like Tamil and Malayalam. There's just less research, fewer data sets, fewer existing tools to build on.
Makes sense. Has there been any prior work in this area for these languages?
There's been growing work on NLP for Dravidian languages generally, sure. But applying it specifically to spotting fake product reviews is relatively new territory. This paper builds on things like, say, fake news detection research in Malayalam, which also found transformers were promising.
So it's taking those general NLP advancements and focusing them on this very specific, very current problem of fake reviews.
Precisely. It's tackling a timely threat to online trust in these specific language communities.
Okay, let's dive into how they did it, the methodology. Tell us about the data they used.
All right, the data set. They used one provided by Premjeth and colleagues. Crucially, it was balanced, meaning roughly equal numbers of AI-generated and human-written reviews for both Tamil and Malayalam.
How many reviews are we talking?
For the training part, it was around 400 AI and 400 human reviews per language. And then for testing, to see how the model's generalized, they had 100 Tamil reviews, split 50-50, and 200 Malayalam reviews, split 100-100.
That balance is key, isn't it? Stops the model just guessing the majority class.
Absolutely. Yeah. And how did they prepare this data for the models? For the traditional ML and the deep learning ones, they did the standard stuff, cleaning the text, removing weird characters or HTML, then tokenizing it, breaking it into words.
Standard text prep.
Yep. And label encoding, turning AI and human into numbers. For features, they used TF-IDF, looking at word importance, and word invec to get numerical word meanings, averaging those for each review. Then they scaled everything so all features had similar weight.
Okay, makes sense for those models. What about the transformers? They often have their own specific needs, right?
They do. For those, they use the auto tokenizer from Hugging Face, which is super handy.
Right.
It automatically formats the text correctly for whatever specific transformer model you're using.
Ah, convenient.
Very. They set a max length of 128 tokens per review, probably for efficiency. Then, during fine-tuning, adapting the pre-trained models, they used a batch size of 16, trained for 3 epochs.
Only 3 epochs.
Yeah, pretty common for fine-tuning. You don't want to overfit. They used a learning rate of 2E5, weight decay of 0.01, ran it on Google Colab's T4 GPUs, and tracked experiments with weights and biases. Fairly standard transformer fine-tuning setup.
Got it. And the deep learning model they used, what was that like?
It was a combination. CNN layers first, then a BIL FTM. The idea is CNN spot local word patterns, and the BIL FTM looks at the whole sequence, forwards and backwards, to get context.
So trying to get the best of both worlds.
Kind of. They also had pooling and dropout layers to help generalization, then dense layers for the final classification. They trained this one longer, for 15 epochs with an atom optimizer and a batch size of 32.
Okay. And lastly, the traditional ML models. How are they trained?
For the SVM, they did a proper hyperparameter search using grid search and cross-validation to find the best settings for things like the kernel and regularization. The Random Forest and XGBoost both used 100 estimators. And then they made that ensemble model by combining Random Forest and XGBoost predictions using soft voting.
Right, averaging their probability scores. Sounds like a very thorough comparison across the board. Let's circle back to the results again. Apart from the top performers, any other takeaways about how the different model types fared?
Yeah, a few things. That ensemble model, the Random Forest plus XGBoost, it did okay for Tamil, but seemed to struggle more with Malayalam.
Suggesting Malayalam might have characteristics harder for those specific models.
Possibly. The CNN plus BIL STM also showed a similar pattern, decent for Tamil, less so for Malayalam. And the SVM, while looking good during validation, seemed to overfit a bit as its performance dropped on the final unseen test set.
So, lessons learned even from the models that didn't top the charts. Did they try to understand why some reviews fooled the models? Look at the language itself.
They did, yeah. They did some qualitative analysis. For instance, in Malayalam, they found AI reviews tended to be shorter, fewer words per sentence on average.
Okay.
But interestingly, those shorter AI Malayalam reviews actually showed higher lexical diversity, used a wider, maybe more unusual range of words compared to humans.
Huh, that's counterintuitive. What about Tamil?
Kind of the opposite trend for word count there. The AI Tamil reviews were often longer, but had lower lexical diversity on the test set. So more words, but maybe more repetitive or using a narrower vocabulary.
Fascinating differences. Did they get any human input on this?
Yes, they surveyed native Tamil and Malayalam speakers, asked them what clues they'd look for to spot AI text. People mentioned things like uncommon words, grammatical mistakes, weird phrasing, sentences not flowing well, kind of subtle stuff humans pick up on.
That qualitative side adds so much color. It shows it's not just about scores, but about understanding the linguistic tells. Now, no study is perfect. What limitations did the authors themselves point out?
They were quite upfront about several things. One was that the transformers they used were pre-trained on general text, not specifically on reviews, which might limit performance.
Makes sense.
Another big one is just the lack of data in low-resource languages. It's always a challenge for really effective fine-tuning.
Right. Anything else?
Yeah, they noted their dataset didn't include code mixing, where people switch between Tamil or Malayalam and English in the same review. That's super common in reality.
Oh, definitely. That's a big gap.
It is. They also mentioned compute limits restricting how much tuning they could do. And because they weren't native speakers themselves, they couldn't do a deep dive into the linguistic errors or potential biases in the misclassified reviews.
Those are all important caveats, and they naturally lead us into thinking about the future. Which brings us to our novel notions segment. Based on this paper, what's an exciting new research direction you see?
Well, building directly on that code mixing limitation, a really compelling idea is to focus specifically on that. We need larger data sets for Tamil, Malayalam, maybe other Dravidian languages that actually contain this mix of languages.
Right, data that reflects reality.
Exactly. And then explore cross-lingual transfer learning. Could you train a model on, say, Tamil English code mix data and have it work better for Malayalam English code mix data with less fine-tuning, leveraging those shared patterns?
That could be powerful, especially for low-resource pairs.
For sure. You could even look into generating synthetic code mix data to boost dataset size and train multilingual models like XLM Roberta on that. If that works, you get detection systems much better suited for real-world online content. It's a potential game changer for these languages.
That really does sound promising. Addressing the way people actually communicate online, what's another novel notion this sparks?
Another angle is to move beyond just the review text. This study was text only. But what if you incorporated metadata, like information about the user who wrote the review?
Their history, how many reviews they've left.
Yeah, purchase history, review patterns, and also product information, category, price, etc. The hypothesis would be that AI-generated reviews might show weird patterns in these user-product interactions.
Like one new user suddenly reviewing tons of unrelated products very positively.
Exactly that kind of thing. You could potentially use something like graph neural networks to model these relationships, users, products, reviews, and spot anomalies that scream AI campaign.
So adding a whole other layer of signals beyond just the words themselves.
Precisely. It's a more holistic approach. Platforms with rich user and product data could find this really valuable for improving authenticity.
Both really interesting directions, moving towards more realistic data and a broader set of signals. Okay, to wrap up our deep dive, what's the main message people should take away from this research?
I think the key thing is that this work really pushes the needle forward in fighting AI-generated fake reviews, especially for languages like Tamil and Malayalam that often get overlooked. It clearly shows transformer models have huge potential here, much more than older methods.
But it's not solved yet.
Definitely not. It highlights ongoing challenges needing better, more diverse data, handling things like code mixing. So while we're making good progress, there's still plenty of work to do. It's very much an active research area.
A crucial one. And that leaves us with a final thought for you, our listener. As AI keeps getting better at mimicking humans, how will we need to adapt our methods, maybe even fundamentally change our approaches, to tell real from fake online? It's a question that goes way beyond just reviews.
It really does. It touches on the future of online trust itself.
Indeed. If you want to get into the nitty-gritty, the link to the paper we discussed is available. Thanks for joining us for this deep dive.